Now let's talk a bit more about the stack trace, how to read the stack trace, as well as exception propagation, okay, between across methods. Now written a very simple main method, one statement which tries to perform an operation which results in an arithmetic exception, a division by zero. Now let me save this and run this. What's going to happen? Okay, it compiles because the checking of whether this operation can be performed, this division by zero can be performed, will happen only during runtime. Okay, let's try to read this. This is a runtime error, and it basically shows stack trace. It says there's a exception in the thread main. So far, all the classes you have written are single threaded programs. Okay, and the thread is called the main thread. Let's not talk about multi-threaded applications yet. This is an advanced topic in Java. Basically, you can have multiple threads running concurrently. You can have the first thread called main, the second thread called T1, third thread called T2, and so on. So far, you have written all the programs you have written are single-threaded programs, and that thread is called main. So exception in the thread main, and this is the exception name, java.lang.exception. Or put it now with this exception type. This is the message. When you call get message of an arithmetic exception object, you get this string. Alright, and this is the important one. They tell you the exception started at line 3 of test.java, and exactly this line. So the short trace, nothing interesting. Now trace will become more interesting very soon when you start calling methods. Now I've written another class called demo. Very simple scatter class just to show you a point. Three methods in demo. Method 1. Now method 1 calls method 2. Okay, when method 2 runs, it calls method 3. When method 3 runs, it performs an operation which causes an arithmetic exception. Okay, so in the test class main method, I'm going to create a new instance of demo, and I'm going to call method 1. Okay, which calls method 2, which calls method 3, which causes an exception. Let's save everything, okay, and see what happens. The stack trace will be more interesting this time round. Look at this. So, same thing, exception in thread main, and the exception type is arithmetic exception. This is the stack trace. It says the exception occurred at line 12 of demo.java. Where is line 12? This is the very first place the exception has occurred. In other words, this is a very root location. Okay. Now, this was in turn called by line 8. Line 8 called line 11, okay, which contains line 12. And this was in turn called by line 4. Line 4 called method 2, which contains method 3, which called method 3, which called, which ran the statement which caused a problem. And in turn, line 4 was caused by test.java's line 4. You see the trace here? It shows you the sequence of method calls, okay, leading to the erroneous condition. This is very useful for checking, okay, the source of problems. This is the root source. The root source may not be your code. The root source, this highlighted thing, may not be your code. It may be code from the Java API library. Okay, in which case you look at who called that method. Okay, if it is your code, you can start working, trying to do debugging there. If it's still not your code, you look at your code which called that line, alright, which called that method, and so on. So this is the stack trace. Now, I'm going to introduce the concept of exception propagation. So basically, an exception has occurred on line 12. If it is not caught, alright, so I can easily try to do this. Okay, you have learned about try and catch, right? I think it's still wrongly spelled. Haha. I've got to do something about my spelling. Okay, in this case, do you think that what do you think your printout will be like? Okay, so main calls method 1, which calls method 2, which calls method 3. I come to method 3, I try to perform this operation, okay, which results in an arithmetic exception called here. Haha is printed out, and method 3 returns to here. Now, as far as method 2 is concerned, nothing went wrong in method 3. Now, this is very important. Why? Not because the exception has been successfully called and handled in method 3. So as far as the caller of method 3 is concerned, as far as this statement is concerned, nothing has gone wrong in method 3. No exception has been thrown. Okay? But in reality, you know that exception has been thrown and caught and successfully handled. And that's why the output looks like this. Okay? Now let's get rid of this. Oops, what am I doing? Okay. Okay, what am I doing here is I'm having a catch block when I call the method 3 method. Save it, compile everything, and run it. Unfortunately, the output does not show the sequence of statements. Okay, the sequence in which the statements are called. Okay, let me go through it manually with you. So line 3 will run, line 4 will run. Okay, line 4 causes jumps to method 1, right? Go to line 4 of demo, jump to line 7, jump to line 8, line 9. From line 9, I jump to line 16. I try to perform this, which results in an arithmetic exception. If there are subsequent statements after line 17 in the method 3 method, they will be ignored. Alright? Now what happens here? There is no catch block for an arithmetic exception in method 3. What happens is the exception, in this case an arithmetic exception object, will be thrown back to the caller of method 3. In other words, it will be thrown back to this statement. Alright? So it will be as if line 9 has caused an arithmetic exception, which will be caught at line 11. Alright? So it will be caught at line 11, you print out haha, and method 2 will complete and return to method 1. So as far as method 1 is concerned, nothing has gone wrong in method 2, because the exception has been handled properly in method 2. So basically the point is that if an exception occurs, okay, if there is a correct exception handler or catch block, it will run and it will be deemed successfully handled. Now, if there's no catch block for that exception, the exception object will be propagated back to the caller of the current method. So from method 3, alright, an exception has occurred. The exception, there's no catch block for this exception in method 3, right? You'll be propagated backwards to method 2, the caller. Luckily, in this case, there's a catch block, okay, and the catch block will run, and the problem is solved. Now, in the situation whereby there is no catch block here, the exception will be propagated back to method 1. If there's a catch block in method 1, you'll be caught there. If there's no catch block in method 1 for arithmetic exception, you'll be propagated back to this statement, okay, in the main method. If there's a catch block here, it will run. If there's no catch block here, it will be propagated back to the caller of main. And the caller of main is your Java virtual machine, and the Java virtual machine has a pretty nasty way of handling exceptions. You just terminate the program and show the stack trace. You have seen it just now. Alright, so that's the default way the JVM will handle exceptions thrown back from main. Terminate the program, show the stack trace. In a real code non-demonstration, or that means live code, you will not want that to happen. You will always want to catch exceptions and recover gracefully, show a proper error message. Lock it, for example. Okay, you do not want to throw an exception back to the Java virtual machine and terminate the program in such an ugly manner. So the point here about exception propagation is that if the exception is not successfully handled, it will be propagated back to the caller until a point it is successfully handled. In other words, there is a relevant catch block which catches the exception, okay, and then it will not be propagated back anymore. Just think of it as I like to think of it like a kind of a game, okay. Okay, the CEO gives the manager a task to do. The manager delegates the task to the the assistant manager, okay, who then gives it to the clerk, for example. So the CEO of the company gives a job to the manager gives the same job to the assistant manager, who in turn gives it to the clerk. Now, if a problem occurs at the level of the clerk, alright, there are two things he can do. He can either catch it and handle the problem, or he can refuse to catch it and propagate the problem back to the assistant manager who gave the task to the clerk. Now, same thing, assistant manager, when he gets a problem from the clerk, he can either handle it at his level if he can do it and he wants to do it, or he may propagate it back to the manager. That means if there's no catch block for that exception in assistant manager, the exception object will be thrown back to the manager. If the manager can handle it with a relevant catch block, so be it. The CEO will not even be aware that a problem has occurred. If the manager does not want to handle it or cannot handle it, that means there's no catch block for the exception. It will be propagated back to the CEO. Alright? Who may then have a catch block to handle it. Okay, the same idea with exceptions. Method 1 calls method 2, method 2 calls method 3. If an exception occurs at method 3, if there's a catch block in method 3 which handles the exception, it will be handled in method 3, and method 2 will be none the wiser that something has gone wrong. Alright? So sometimes it is not that the clerk does not want to handle his exception. Sometimes he cannot handle the exception and he has to propagate the problem back to his supervisor, the assistant manager. Okay, so when you write code, you will decide where exceptions should be handled. Okay?